All right, mathletes, here we are studying axis intercepts here for quadratic. So, first thing we're going to talk about is x-intercepts. Notice our x-intercepts are always going to happen when we let y be equal to 0. So, there's our x-intercepts. Notice that our y-intercepts, okay, where they cross the y-axis, is when we let x is equal to 0. So, when x is 0, notice x is 0, we find our y-intercept. Okay, so finding our y-intercept, it's very convenient when we have it in our standard form here, and we can just identify our c value, and that is our constant term, so that is our y-intercept. Very similar to when we were graphing linear functions, when you had y equals mx plus b, and that b value was our y-intercept. Well, now we can say the same thing for our c value. Well, we know this is true because if we evaluate our function when x is equal to 0 for our y-intercepts, we get a times 0 squared plus b times 0. No matter what a and b are, when you multiply them by 0, you get 0 plus 0. This is plus c, and 0 plus 0 is equal to c, and that's our proof why it must be c for our y-intercept. Okay? Now for our x-intercepts, the thing we have to remember, it's the same thing as solving our quadratic equation for 0. We had just talked about that we have different tools of solving for quadratics. We have our quadratic equation, solving by factoring and completing the square. When doing so, we can get two solutions. And graphically, when we get two solutions, this happens when our parabola crosses our axes twice. We can get one solution. Sometimes we call this a double root. Okay? And that happens here, and we only get one intercept. And sometimes we'll get parabolas that don't cross our x-axis at all, okay, and there's no intercepts. Okay, it's very helpful, just like when we're solving quadratics. If we put it into our factored form, from there we can easily identify our x-intercepts as being the values. When I plug it into this function, it's going to be equal to 0, and when I plug it into this part of the function, it's going to be equal to 0, and I find my x-intercepts. So let's look at some examples here. Okay, so find the x-intercepts of the quadratic functions. Okay, so finding x-intercepts, the first thing I'm going to do is I'm going to try and factor. Okay, so if I have 9 and negative 6, I'm going to have minus 3, so I get x squared minus 3x minus 3x plus 9. Factor out a 3, I get x minus 3. Factor out a negative 3. Or wait, sorry, this was factoring out an x, and this is factoring out a negative 3. And I get x minus 3 equal to 0. And I get a x minus 3 and x minus 3. So this is a double root. They're the same. So my x-intercepts happen when this is equal to 0. So x is equal to positive 3. And that is my x-intercept. So I know that this function is going to have at 1, 2, 3, I have a single x-intercept passing right through when x is equal to 3. Okay? Second part here, if I'm going to solve this quadratic, I have 0 equals negative x squared minus x plus 6. Remember, I always like it when this value is positive, my a value, so I'm going to move it to the other side, so I get x squared plus x minus 6 is equal to 0. Now I can try and solve by factoring, and I'm going to get negative 6 and adding to 1, so I'm going to get 3 and negative 2. Using my shortcut for factoring, I know this is going to be x plus 3 and x minus 2 is equal to 0. So that gives me two solutions, one when x is equal to negative 3 from the first one, and one when x is equal to 2 on the other solution. And these two are my x-intercepts. If I'm thinking about my graph here, okay, when x is equal to negative 3, okay, I have a intercept, okay? And when x is equal to 2, I have another intercept, okay? But because I have a value up here that's -1, I'm going to have a concave down graph. And I'd have a graph that looks something like this. Okay? Let's look at another example here. Use the quadratic formula to find the x-intercepts. So here, notice, I want to be able to factor this. So I'm going to find my x-intercepts by my quadratic formula. So first I identify my a, and my b, and my c terms. And I have a is equal to 1, b is equal to -2, c is equal to -5. So my quadratic equation is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So now I substitute in my values. So I have -2 plus or minus the square root of b squared, so -2 squared minus 4 times a times c. Okay, all over 2 times a. So as I simplify this out, I get 2 plus or minus the square root of 4. -4 times 1 times -5 is going to be plus 20. Okay, and this is all divided by 2. So then simplifying more, I get 2 plus or minus the square root of 24 divided by 2. Okay, so at this point I want to plug this into my calculator and get a decimal answer, so I actually know what those x-intercepts are where they would cross the x-axis. So if I do 2 plus the square root of 24, and then I divide that by 2, I'm going to get one answer of 3.45. And now if I do the same thing but switching it to 2 minus the square root of 24 divided by 2, I'm going to get the second answer of -1.449. Those would be my x-intercepts for that graph. Okay, so putting all these different things together, I want to sketch the graph of each quadratic function here. Okay, or for this particular quadratic function, by putting these 3 key points in, or using these 3 concepts to get a general sketch for this graph. So, a value. Well, my a value is equal to 1. I know that must be concave up. Okay, and it's not going to be any wider or narrower. Okay, 2, my y-intercept. Well, my y-intercept, it happens when x is equal to 0, or it's my c value. So my c value is -3. So I can graph this point, and I can see right here, my graph is going to go through, oh, sorry, that's +3, so it's going to go through -3 there. Okay, next thing I want to do is I want to find my x-intercepts. So I'm going to set my y equal to 0. I get 0 equals x squared minus 2x minus 3. So I'm going to solve this one, see if I can solve it by factoring. So I get -3, -2, and I can do -3 and 1. So as I factor this, I get x minus 3 and an x plus 1. That gives intercepts at y equals 3, or x equals 3, and x equals -1. So I put that on my graph at x equals 3 and x equals -1. Okay, I have a general idea of my graph here now, and I know it's concave up because my a value, so I can just kind of connect the dots and get a general sketch of my quadratic here. Let's look at one last example here. So this one is different because it's already in factored form. Okay, but first thing I'm going to do is identify my a value. So my a value is equal to -2. So I know this is going to be a slightly skinnier parabola, and it's going to be concave down because it's negative. Okay, the x-intercepts. Okay, so, or I'm sorry, the y-intercept. Okay, well, because it's not, I don't have a c value, it's not here, I'm going to remember that happens when x is equal to 0. So if I plug it into my function, So I get negative 2 times 0 plus 1 and 0 minus 2. Well, what am I going to get? I'm going to get negative 2 times 1 times negative 2. So I'm going to get that equal to 4. So I know my y-intercept is 4. Now, last piece is find my x-intercepts. Well, that's easy because I'm already in factored form. So what makes this equal to 0? Well, that's x equals negative 1. So x equals negative 1. What makes this equal to 0? That's when x is equal to positive 2. And I have positive 2 here. So now, because I know it's concave down, because my a value is negative, I can do a general sketch here of a parabola. Notice it's skinnier than other ones because my a value is 2. That's going to conclude the notes for tonight. Please highlight any questions and bring them to class tomorrow.